Dear students, let me welcome you all to today's session. Today we are going to learn and understand the concepts related to probability. Let me start with some of the basic concepts. All right. Dear students, you all are aware that probability, it basically tries to quantify the chance of occurrence of a event or of an event. Okay. So the basic formula you all should know as far as probability it is concerned. Probability for a particular event P of E, it is equal to, it's actually a ratio, I should say. Okay. So in the denominator side, it corresponds to total number of outcomes. Okay. And in the numerator, it will be about the number of favorable outcomes. Okay. So I shall just write it here. The chance of occurrence of an event, if I'm going to quantify it, it is basically a ratio. Probability for a particular event, it is number of favorable outcome divided by total number of outcome. Let us quickly try to understand some words like sample space. Okay. And then another important word, that is event. The moment you are able to connect these two, then the discussion on probability, it will become a simple task. Consider the example that you are rolling a dice. Now, when you are rolling a dice, the set of all possible outcome, if I am going to write it, you may see a 1 or a 2 or a 3 or a 4 or a 5 or a 6, right? These are the possible outcomes when you are rolling a dice. I am saying that the dice, it is unbiased. So when you are rolling an unbiased dice, you may end up seeing 1 or a 2 or a 3 or a 4 or a 5 or a 6. Okay. So this is nothing but the set of all possible outcomes when you are performing an experiment. That is called as the sample space. Now, within the sample space, you will be defining a particular event. It will be like, say, you see an even number. Okay. Or you are getting an even number. Getting an even number. Okay, when you are rolling a dice, you are getting an even number. That getting an even number, it is an event which I am defining. Getting a prime number. Okay, getting a prime number. That is another event which I am defining. Okay, so like this, I can define various events when I am performing this experiment. So probability basically tries to quantify the chance of occurrence of an event. It put it in numbers. I hope it is clear to you. The total number of outcome, it corresponds to, or it has got direct relation with the sample space. The number of elements in the sample space, I can consider that is equal to the total number of outcome. Okay. Now you are defining an event. So the event is something like, say, getting an even number or getting a prime number, like that. Okay. So there you see the sample space and see how many times this particular event it is happening. So that is nothing but the number of favorable outcome. Okay. So this part is basically a subset of the sample space. Okay. So we can consider that probability, the chance of occurrence of an event, is total number of favorable outcome divided by total number of outcome. And quickly recall, this probability value it lies between 0 to 1. Okay, this value, it lies between 0% to 100%. Percentage wise, when I am saying the probability for a particular event, you are aware, it will lie always between 0 to 1 if it is expressed in the ratio format, 0% to 100% if you are representing it in the percentage format. Okay, so this one you have to remember. Also, if I say probability of occurrence of an event, it is P of E. The probability that the event it does not happen, the probability that the event E does not occur, it is 1 minus probability that the event E is happening. For example, I say that probability for rain today. Okay, the probability is going to rain today. Let me say that it is equal to 70%. Okay, automatically it means that probability that it is not going to rain. I will write it as probability that it's not going to rain. It will be 100 minus 70, that is equal to 30%. Okay, so if there is 70% chance that it is going to rain, automatically it means that 30% chance that it is not going to rain. Make a note of this aspect. Okay, now also remember probability that an event A or B, it happens, P of A union B, it is equal to probability that the event A happens plus probability that the event B happens minus probability that the event A and B it happens. In set theory, we have something called as N of A union B, right? N of A union B is N of A plus N of B minus N of A intersection B. You're just replacing that N with that P, the probability aspect. So probability that the event A or B happens, it is equal to probability that A happens plus probability that B happens minus probability that the event A and B it happens. And here it goes, this P of A intersection B, recall, there are two instances. P of A intersection B. Listen carefully. There are two situations there. Sometimes the event A and B, they will be mutually exclusive. Okay. If A and B are mutually exclusive, okay. Mutually exclusive means happening of A will prevent the happening of B. Happening of B will prevent the happening of A. So if A and B, they are mutually exclusive, please understand P of A intersection B, it will be equal to 0. For example, the tossing of a coin. Okay, tossing a coin. When you are tossing a coin, you are aware that you may get either a heads or a tails. What is the chance that you are going to get a heads and a tails? Happening of head will prevent the happening of tail. Happening of tail will prevent the happening of heads. So we can see that tossing a coin is a scenario where the events are mutually exclusive. In that case, probability that you end up seeing heads and tails, that is equal to 0. Okay, so as far as P of A intersection B is concerned, if the events defined they are mutually exclusive, P of A intersection B, it is equal to 0. Else, the situation is A and B, we consider them as independent. Okay, if they are independent events, then P of A intersection B, that will be equal to P of A into P of B. Okay, so these particular concepts and this equation you are going to very much use while we are going to solve the problems. So make a note of this: P of A union B, P of A plus P of B minus P of A intersection B. P of A intersection B. Two situations are there. Events can be mutually exclusive or they can be independent. If they are mutually exclusive, P of A intersection B will be 0. If they are independent, P of A intersection B is equal to P of A into P of B. Like that, it will come. Okay. Now, there is something called as odds in favor and odds against an event. Let me say that probability that an event E happens. Okay. Let me say it is equal to A. Some value. Okay. Probability that event E happens, it is A. Okay. So the probability that the event E does not happen, it is nothing but 1 minus A. Okay. So please note odds in favor. Odds in favor means what? Probability that the event E happens upon probability that the event E, it does not happen. This is odds in favor. And mathematically, it is A by 1 minus A. Okay. So please make a note of this. This is odds in favor. Okay. Now, there is one more concept, odds against an event. Against. Odds against an event. Odds against an event will be probability that the event E does not happen upon probability that the event E, it happens. And this is nothing but 1 minus A upon A. Got it? So you should be familiar with these two terminologies, odds in favor and odds against an event, what it actually corresponds to. Okay, so at least these points, quickly, if you have revised and understood, solving problems related to probability, it will be a very easy task. Okay, so let's now consider the first question here. From a collection of 10 books, out of which 6 are biographies and the rest are autobiographies. So total number of books, it is 10. Two categories are there. One is biographies. The other one is autobiographies. It is given that 6 are biographies. The remaining 4 are autobiographies. It is given that 2 books are selected simultaneously at random. The question is, what is the probability that one is a biography and the other is an autobiography? Kindly note the word that is considered here, and. Okay. So the condition is that 2 books are selected simultaneously. So the number of ways you can do this, selecting 2 books from 10 available. You know what it is? The number of ways you can select 2 books from 10 available, it is 10C2. So the sample space, when you consider, it is 10C2. The number of ways of selecting 2 books out of 10 books available, it is 10C2. Okay. Now, in this selection, what is the chance that one is a biography and the other is an autobiography? So from 6 biography, it should be 1. From 4 autobiography, you should select 1. How many ways you can do it? From 6, you are selecting 1. That can happen in 6C1 ways. From 4, you are selecting 1. This can happen 4C1 ways. So the total number of ways when you are considering 1 being biography and 1 being autobiography, the total number of ways this can be done will be 6C1 into 4C1. So we can see that the total number of favorable outcome, it will be 6C1 into 4C1. The total number of outcome is 10C2. So probability that one is a biography and the other is an autobiography, it will be 6C1 into 4C1 upon 10C2. Upon calculation, we can see that here, this will get you the answer 8 upon 15. Looking at the options, we can say option A, it reads 8 by 50. So for the first question, this is our answer. Okay. Now, the second part of the question, it says, the same condition, it says, 2 books are selected at random. What is the probability that both are autobiographies? So here also, the total number of outcome when I am considering, from 10, you are selecting 2 at random simultaneously. So 10C2 ways. Okay, so that's the sample space. Now, in this 10C2, the question is, what is the chance that both are autobiographies? So 4 autobiographies are there. You end up selecting 2 out of them. So the total number of favorable outcome, it will be 4C2. So our answer, it will be 4C2 upon 10C2, it will come. Both are autobiographies, 4C2. Total number of outcome, it is 10C2. So 4C2 by 10C2, when you do, you will get the result here as 2 upon 50. You are aware 4C2 is nothing but 4 into 3 upon 1 into 2. 10C2, it is as good as 10 into 9 upon 1 into 2. So here we can see that this 1 into 2, it will get cancelled. This will come here as 12 upon 90. Cancelling this here with 6, I can see that 6 2s are 12 and 15 into 6, it is equal to 90. So that is how you are getting it as 2 upon 50. You can cancel it with 60, 12 by 90, cancelling it with 6. Whatever it is, cancelling it with 6, we can see that here the answer will come as 2 by 50. Looking at the options, option B, it reads 2 by 50. So for our question, option B will be our final answer. So that brings conclusion to our first question for the day. Let's go to the next one. Here you can see that a box, it contains 10 cards. So total number of cards, it is 10. 7 of these cards have the letter I printed on them. So we can see that the letter I in 7 cards, it is printed. And the others have the letter M printed on them. So the letter M, others. So when they say others, you can say it is corresponding to 3 in number. So 7 cards with the letter I and 3 cards with the letter M. 7 plus 3, 10 cards. Okay. Now, listen carefully. It is given if 3 cards are picked up one after the other at random and placed on a table. Here, you are picking one card after the other. You are not picking all 3 simultaneously. Okay. So you are taking the first card, you are placing it on the table. You are taking the second card, you are placing it on the table. You are taking the third card, placing it on the table. So you are taking these 3 cards or picking up these 3 cards one after the other, and you are placing them on the table in that order. The question is, what is the probability that the word so formed, it is I-I-M? Okay, so for that, the first selected card, it should contain the letter I. So we can see here the probability that the first one, it is going to be I. It is 7 upon 10. Okay, so we can see that one card is selected. It is becoming I. The probability that it is 7 out of 10, and you have placed that card. Now, when you go for the second draw, you can see that there are only 9 cards available because one card already gone. So from that 9, you have to pick up again the letter I. You can see that one card in which I it is written, you have already taken. So we can see that after the first thing it is over, the situation will be 9 cards are available. Letter I, 6. Letter M, you can say 3 are there, right? After the first draw, it is over. Then you are left with 9 cards. 6 are there, I, and 3 are there, M. So the question is, what is the probability that the second one that you are selecting, it is also letter I? What it will be? It will be 6 by 9. Got it? Because there are 6 favorable outcome divided by total number of outcome 9. So that is also I. Now you are left with 8 cards. If you observe, 5 of them letter I, 3 of them letter M. The third one that you are selecting, it should be the letter M. And what is the probability for that? Out of 8 available, 3 favorable outcome, right? So we can see 8 cards are altogether available. Favorable outcome, it is 3. So 7 by 10 into 6 by 9 into 3 by 8. This is going to be the required probability. Okay, so when I'm simplifying it, it will be 7 into 6 into 3 by 10 into 9 into 8. On simplification, I can say this will come here as 7 upon 40. Okay, we can see that here 6 and 3 are available, right? So you can see that this 3, it will go here 3 times. That will go in 6. You can see that 2 times. This 2 will go in 10, 5 times. So it comes as 7 upon 5 eighths are 40. 7 by 40. So the probability that the so formed word, it is IIM. You can see that probability value, it is equal to 7 upon 40. That's for the second question. Now let us consider the next question here. It is given when a fair coin is tossed 9 times, find the probability of getting heads at least once. Let us consider when the coin is tossed once. Okay, the coin is tossed once. You may get a heads or you may get a tails. So two outcomes are possible. Okay, two outcomes. Now, consider that you are throwing or tossing the coin 2 times. Okay, twice. So you can see the total number of outcomes, it will be 2 into 2, that is equal to 4. 4 outcomes. It may be like head, 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 tail, tail, head, tail, tail. Okay, these are the possible outcomes I am saying. So, likewise, when you are tossing a fair coin 9 times, you can see that the total number of outcomes, that will be equal to 2 power 9, which is equal to 512. Okay, so that's the total number of outcomes. You're tossing the coin 9 times, 512 outcomes are possible. Now, the question is, find the probability that you are going to get heads at least once. So for answering this question, what I am going to do is, first I will find out what is the probability that I am going to get no head at all. No head at all. Which means all are going to be tails. Okay, probability that no head at all. Which means all are going to be tails. You can see that it will be corresponding to 1 out of 512. Because tail, 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 tail. That is going to happen only once. Right? So no head. All of them are tails. It is 1 by 512. Now read the question carefully. They are saying that it is not the case that they are asking you. What is the probability that you are going to get heads at least once? It's not that you are never going to get heads at all. It should be coming at least once. So what is the required probability? Therefore, probability that head it comes at least once. That will be nothing but 1 minus 1 by 512. They are saying that it is not this case, which means my answer is 1 minus 1 by 512, and that is equal to 511 divided by 512. Okay, so option B, it reads 511 upon 512. That is going to be my answer. So please be careful with this approach. What is the probability that you are going to get at least once this heads? So for that, what you have to do is find the probability that head is never going to happen. But that is not what it is asked. Okay, so 1 minus 1 by 512, 511 by 512, that is going to be my answer. Okay, now let's move on to the next question. This is a very interesting question. An unbiased coin is tossed until it shows up the same face in 2 consecutive throws. What is the probability that the number of tosses is not more than 4, which means you can support up to 4 tosses, but it's not exceeding 4. What is the probability that you are going to get? Okay, within that, what's the probability that you are going to get or you end up seeing the same face in 2 consecutive throws? So let us consider the number of throws. The number of throws, it may be 2 or it may be 3 or maximum it is going to be 4. Now let me present in front of you the cases. The number of throw, it is equal to 2. Then you may be getting something like head and head, or you may be getting a situation like you are getting tail and tail. So you can see that when you are tossing it twice, the success it happens if you end up seeing head head or you end up seeing tail tail. Okay, so that is one. Now in the same way, if the number of throws it is equal to 3 throws, it is equal to 3. You can see the success will happen if it is like head, tail, tail, or tail, head, head. Got it? So you can see here also in successive throws, you end up seeing the same face. So number of throws 3, this is how the success comes. And in the same way, the last one, the number of throws, this is equal to 4. And how the success it comes? You see the heads, then you see the tails, then you see the heads, then you see the heads. Or it will be first you see the tails, then you end up seeing the heads, then you see the tail, then you see the tail. So these are the instances when I say wherein the number of tosses is not more than 4. It is either 2 or 3 or 4. But you end up seeing the same face in 2 consecutive throws. You can say that happens here. You can see that is happening here. Okay, head, head also. That is happening here. Head, head, tail, tail. Like that it is. Now the question is, what is the probability? Okay, so for that, you have to understand that the total number of outcome under consideration. Okay, as I indicated, you can see that here. Just a second. Let us deal with the case where there are 2 throws. Okay, so we can see that there are 2 instances, right? The first one being head, the probability it is 1 by 2. Here also this comes as 1 by 2. Or it being tail, you can see that it is 1 by 2, 1 by 2. Okay, it's an unbiased coin you are tossing. Okay, so we can see that this is what it happens when you are making 2 throws. In the same way, if it's 3, then it is 1 by 2 into 1 by 2 into 1 by 2. That is the case for HTT. Or it is again 1 by 2 into 1 by 2 into 1 by 2. Okay. In the same way, you can see that if the number of throws it is equal to 4, it will be 1 by 2 power 4 or again 1 by 2 power 4. The first one, 1 by 2 power 4, it is for HTHH or THTT. Like that, this is coming. Okay. I am writing it with high resolution here so that you are able to understand it perfectly. So in a simplified version, I can say it will be 2 times 1 by 2 square plus 1 by 2 cube plus 1 by 2 power 4. On simplification, we can say this results in 7 by 8. The simplification part, I am leaving it to you. On simplification, 2 times 1 by 4 plus 1 by 8 plus 1 by 16 when you do, the answer, it will come here as 7 by 8. So the probability we are considering here, we can write it, it is equal to 7 by 8. Okay. The number of tosses is not more than 4. That's what we are considering. That is coming here as 7 by 8. Okay. So that is for this particular question. Let's now move on to the next one. You can see that a bag contains 4 5 rupee coins. So 5 rupee coins. You can see there are 4 in number. 3 2 rupee coins. So 2 rupee coins. We can see that 3 in number. And we can see that 3 1 rupee coins. Okay, so 1 rupee, 3 in number. Total number of coins, if you consider, it is 4, 5, 6, 7, 8, 9, 10. So altogether, you can see that there are 10 coins. Now, I wrote all these things here, okay? The ideal way, it is while you are attempting the question, when you are reading this part, here itself, all these inputs, it should be captured in your mind. And by the time you have finished reading from here to here, you are sure about all these points what I have mentioned, and also you should be ready with the number of coins that you are dealing with in this question. Now see, if 6 coins are drawn from the bag at random, which means you are putting your hands and you are drawing 6 coins simultaneously. The question is, what are the odds in favor of the draw yielding maximum amount? Okay, so the total number of outcome, it will be the total number of outcome. Okay, it's something like you are putting your hands, you are drawing 6 coins. Okay, so 10 coins are available, you are drawing 6 coins. The total number of outcome, it will be 10C6. Selecting 6 from 10 available, it is 10C6. This is the total number of outcome. Now, in this total number of outcome, what is the chance that you are going to get the maximum, I should say the amount. Maximum amount will happen, when you end up selecting all 4 5 rupee coins and 2 2 rupee coins. Listen carefully, all 4 what you select 5 rupee coins, because you are picking up all the coins with maximum denomination. Okay, 5 rupee coins, there are 4 in number. So you're selecting all 4 of them. And then the remaining 2 rupee coins. Okay. So please note, you are selecting 4 out of 4 available. You are selecting 2 rupee coins out of 3 available. That is the instance where you are going to get the maximum yield. So what is that probability? Probability that maximum yield, it happens. Okay, how much it will be? That is equal to 4C4 and 3C2 upon total number of outcome, that is 10C6. I hope this part is clear to you. You are selecting all 4 5 rupee coins and 2 2 rupee coins. Okay, from 3 available. So 4C4 into 3C2 upon total, it is 10C6. You are drawing 4 plus 2, 6 coins, 10C6. Okay. So this results, that is the probability for that maximum yield when I am considering 4C4 into 3C2 divided by 10C6 when I calculate, you can see this results in 1 by 70. Got it? Now, this is a very critical value, that 1 by 70, based on which I am going to explain the question further. So we can see probability that the success happens, the event happens, it is equal to 1 by 70. That's what I have calculated. So what is the probability that the yield is not maximum, that is P of E bar? It is 1 minus 1 by 70. That is equal to 69 upon 70. So this is the chance that the yield is not maximum, P of E bar. Now the question is, what are the odds in favor of maximum yield? That is nothing but odds in favor is what they have told you. So that is P of E divided by P of E bar. Got it? So we can say this will be 1 upon 70 divided by 69 upon 70. On further simplification, that 70 will get cancelled off. I see that this is coming as 1 by 69. Ratio wise, when I am writing it, I can say it is 1 is to 69. Please note, this is the final answer. The odds in favor that the yield is maximum, it is 1 is to 69. And that brings conclusion to our question number 5 in this lecture. Okay, let's now move on to the next question, the sixth one. It's another interesting question. It has got something to do with quadratic equation and also probability and some number. Okay, number related inputs. What is the probability that a quadratic equation ax square plus bx plus c equal to 0, it has equal roots if a, comma, b, comma, and c are distinct. This is very important. A, B, C, they all are distinct and they are taken from the set 1, 2, 3, 4, 6, 8, 9. If you look at it, 1, 2, 3, 4, 6, 8, 9, you can see that there are 7 numbers. Okay. Now, you have to pick 3 from the 7 available. Listen carefully, you have to pick 3 from this 7 available. How many ways that it can be done? You can see that that is nothing but 7C3. Okay, so now you have selected 3. Now you have to assign those 3 to A, B, and C. How many ways you can do it? You can get this done in 3 factorial ways. In other words, I can see that the total number of ways in which you can allocate values to A, B, and C, it will be 7 into 6 into 5. Just observe A, B, C. They are waiting here. Okay, you can consider that A, it can take any of the 7 values. And out of that one, it goes to A. So when it comes to B's turn, 6 are available. So one value is assigned to B. So out of 7, 2 gone, 5 remaining. One of those 5 values C will take. Got it? So the total number of ways I can assign numbers or I can assign values to A, B, and C, it will be 7 into 6 into 5. That is equal to 210. Please be aware of this part. 1, 2, 3, 4, 6, 8, 9. Those 7 numbers, they are there. Altogether in 210 ways, you can assign these numbers 1, 2, 3, 4, 6, 8, 9 to these A, B, and C in 210 ways. Okay, now this is nothing but the total number of outcome or the sample space and all. Okay, now listen very carefully. We have to satisfy the condition that B square minus 4AC, the discriminant, it is equal to 0. Okay, so you have to select values for this A, B, and C in such a way that you end up getting B square minus 4AC. This is equal to 0. Or you should have B square, it is equal to 4AC. You should have something like this. Now, you can see that A, B, and C, they are going to take values from 1, 2, 3, 4, 6, 8, and 9. Out of this, where A, B, C, they are distinct, I can see that this B, if it is 6, you can see that A, if it takes the value, I can consider say 1, and this value, I can see C, it takes the number 9. Okay, look at this, B is 6, A is 1, and C is 9. You can see that B square minus 4AC is equal to 0, or B square is equal to 4AC. Observe this, it's 6 square 36 is equal to 4 into 1 into 9. And this is the situation where when B square minus 4AC equal to 0, you can see that the roots are equal. Got it? So 169 is a possibility. In the similar way, we can also consider B being 6, A is 9, and the C is 1. Here also you can say B square minus 4AC. You can see that is equal to 0. Discriminant is 0 means what? You can see that the roots are equal. And in this given set, that is 1, 2, 3, 4, 6, 8, 9, wherein A, B, C, they are distinct, satisfying that condition, you can see that there are two instances where B square minus 4AC becomes 0. So the total number of favorable outcome, it is 2 out of total number of outcome, which is 2, 1, 0. Thus, I can see that the probability that the quadratic equation, it has got equal roots. You know, it is 2 by 120, which is 1 by 105. And we can say option C, it reads 1 by 105. That is going to be my answer. Okay, so that brings conclusion to my question number 6. Let's go to question number 7. Varun throws two unbiased dice together and he gets a sum of 7. So the sum what Varun got, it is equal to 7. Now his friend Tarun now throws the same two dice. The question is, what is the probability that the sum is lesser than 7? Which means you can consider that when two dice are thrown, okay, total number of outcome, the total number of outcome, just a second. Okay, just a second. Yeah. Total number of outcome, when you are considering when two dice are thrown, you can see that that is equal to 36. Okay. Now, in this 36, we have to find out the number of instances where the sum, it is less than 7. So that's what I am now trying to consider. Okay. So just a second. The sum, it should go less than 7. So how many instances are there? Let's consider that. We can see that 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. They all, when you consider, you can see that the sum is less than 7. In the same way, 2, 1, 2, 2, 2, 3, 2, 4. These are the instances where you can see that the sum, it is less than 7. We can have 3, 1, 3, 2, 3, 3. You can take 3, 4 because 3, 4 means the sum what you observe will become equal to 7. We are asked to find the sum should be lesser than 7. Okay, so these three instances. Then you can say we have 4, 1, 4, 2, and finally we can say 5, 1. Okay, so these are the favorable outcomes here, wherein when Tarun throws the same two dice, you can see that the sum that Tarun sees, it is less than this 7. See, in every instance I have presented here, the sum, it is less than 7. So how many instances are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the total number of favorable outcome, you can say it is 15. By total number of outcome, that is equal to 36. So we can see that here, cancelling this guy with 3, it will become 5 upon 12. Got it? So this is the probability that the sum, what Tarun sees, is lesser than the 7, 5 by 12. This is my final answer. Okay. So this brings conclusion to the 7th question in this lecture. Let's now go to the next question, the eighth one. Find the odds against throwing 6 at least once with a single die in 3 trials. Lot of inputs are given. See, odds against the event. What is the event? Throwing 6 at least once with a single die in 3 trials. So, let me do one thing. I'll make it simple. What is the probability that when you are throwing the dice once, you are not getting 6? What is that? It is equal to 5 by 6. Okay, listen very carefully. You are throwing a dice. The total number of outcome, you know, it is 6. Out of the 6, you are not going to get 6. So what is the probability that you are not going to get 6? It is 5 upon 6. And this happens when you are throwing the dice once. Okay, so now let us consider P. It is not going to give you 6 in 3 trials. Okay, so you can see that will be nothing but 5 by 6 into 5 by 6 into 5 by 6. Okay, that is equal to 125 upon 216. So in these 3 trials, you can see that you are not getting 6 at all. You know, that is equal to 125 by 216. Now let us find out, therefore, what is the probability that you get 6 at least once? Probability that you get 6 at least once. You see 6. Okay, what is that? It is not never 6. Okay, so it is 1 minus 125 divided by 216. And when I do that calculation, I can see that here, this is equal to 91 divided by 216. So this is the probability that you end up seeing the 6 at least once. Okay, so I am saying P of E here, it is equal to 91 by 216. So what is, because you see the question here, find the odds against throwing 6 at least once. That is what it is asked. So what is that P of E bar? You can see that it will be 1 minus 91 by 216. You know, it is 125 divided by 216. Okay. Now we got those two values ready. You are asked to find the odds against the event. So what is that you are expected to find out? You are asked to find out what is this P of E bar divided by P of E. And you can see this will be coming like 125 upon 216 divided by 91 upon 216. You can see that here the 216 will get cancelled off. So our answer, you know, it will be 125 upon 91 it will come. So the odds against the event, it will be 125 is to 91. Option C, it reads 125 is to 91, and that is my answer here. Okay, so please make a note of this. It's a very, I should say the words, they have played with the words very well in this question. They have said odds against. Against what? Throwing the 6 at least once with a single die. And it is talking in terms of 3 trials. Okay, so this is a very critical and interesting question. Take care of it properly. The final answer, you know, it will be coming as 125 upon 91, option C. That is going to be our answer. Okay, so that brings conclusion to the 8th question in this lecture. Let us now go ahead with the next one, the 9th one. It's given that 4 fair dice are thrown together. Okay, dice, once you throw 6 outcome. So you are throwing 4 fair dice. You are throwing them together. Okay, so here itself, when you read this, you should understand the total number of outcome, it will be 6 power 4. When you throw it once, 6 outcome. When you throw it twice, it is 6 into 6, 36 outcomes. When you are throwing it thrice, it is 6 into 6 into 6, 216 outcomes. You are throwing it 4 times. Okay, 4 fair dice are thrown together. Both are one and the same. So you can see the total number of outcome will be 6 power 4. Okay, now look at this. In the question, you are asked to find if P tells you that it's a probability that you are going to get the score as 20. Q, it's a probability that you are going to get the sum of the scores as 21. You are asked to find what is P is to Q. Okay, so let us consider the instances where the sum it is equal to 20. Let us consider the instances when the sum, it is equal to 21. So it can happen like 6, 6, 6, 2. Sorry, yeah, 6, 6, 6, 2. This is the chance that the sum is becoming 20. It could be like 6, 6, 5, 3. 6 plus 6, 12. 12 plus 3, 15. 15 plus 5, it is equal to 20. It comes that way. It could be like 6, 6, 4, 4. Here also you can see that the sum is becoming 20. Then it could be 6, 5, 5, 4. This is another instance where you can see that the sum is becoming equal to 20. It could also be 5, 5, 5, 5. So altogether you can say 1, 2, 3, 4, 5. 5 different ways where the sum is becoming 20. Okay, irrespective of that order, the 5 instances we can see. You see in 6, 6, 6 and then 2 or 6, 6, 5, 3, 6, 6, 4, 4, 6, 5, 5, 4. You can see everywhere when you add the total is coming as 20 only. In the same way, the sum becoming 21, it can be like 6, 6, 6, 3. Okay, it could be like 6, 6, 5, 4. It could be 6, 6, 6, 3. It could be 6. 1 second. 6, 6, 5, 4. Okay. What I am doing here is I am reducing this guy by 1 and incrementing it by 1. So the total is coming as 21. Or it could be like 6, 5, 5, 5. So these are the instances wherein you can see the sum is becoming 21. Okay. So now let me try to quantify and say how many ways this can be done. This can be achieved. 6662. This can happen altogether in 4 factorial upon 3 factorial ways, that is equal to in 4 ways this can be done. How? 6662, 6626, 6266, 2666. That's the 4 I am talking about. Okay. Now, 6653. In how many ways this can be done? That is 4 factorial upon the 6 is repeating twice, right? 2 factorial. I can say that is equal to in 12 ways. I can arrange that 6, 6, 5 and 3 in such a way that the total is coming as equal to 20. Here I can say it will be 4 factorial divided by 2 factorial into 2 factorial, because you can say the 6 is happening twice, the 4 is happening twice. Permutation with repetition of numbers. That's what basically I'm considering here. So 4 factorial by 2 factorial into 2 factorial. I can see that here the number of ways I can get this thing done, it is equal to 6. For example, it could be like 6, 6, 4, 4. 6, 4, 4, 6. Okay. 6, 4, 6, 4. Like that. Okay. you can consider that there are 6 different ways wherein you can arrange that 6, 6, 4 and 4 so that the total is coming as 20. Okay. Now here 6554, again you can say it is 4 factorial divided by 2 factorial, and that is equal to 12. And 5555, only one way it will come. It is 4 factorial by 4 factorial. You can say only one way it comes. So the total number of ways in which this sum, it is equal to 20, how much it will be. You can see that 12 plus 12, 24, plus 1, 25, plus 6 plus 4, the total comes here as 35. There are 35 ways wherein you can get the sum, it is equal to 20 when you are choosing 4 fair dice. Okay. Likewise, sum 21. Look at this. This is 4 factorial upon 3 factorial. I can see that is equal to 4. You can see that here 6654. This is nothing but 4 factorial upon 2 factorial. You already know that value, it is equal to 12. And this is again 4 factorial upon 3 factorial, that is equal to 4. So the total number of ways the sum 21 can be achieved, it will be equal to 12 plus 4, 16 plus 4, that is equal to 20. Now let us find out what is the value for P. P means what? The probability that the sum is 20. That will be 35 divided by 6 power 4. What is Q? Q is the probability that the sum is 21. That is 20 instances out of 6 power 4. Now they are asking you to find what is P is to Q. So you can very clearly see that here P is to Q is what? It's as good as P by Q. Okay, so when you do P is to Q, this will be coming as the 6 power 4 will get cancelled off. 35 is to 20 it will come. Common factor 5 if I take out, I can say this comes as 7 is to 4. So looking at the options, option D, you can see it reads 7 is to 4. And yes, that is going to be my answer here. Okay, option D, 7 is to 4. So the thing is, this question becomes slightly challenging because you should be considering all those instances where the sum, the unique instances where the sum is becoming 20, the sum is becoming 21. If you accidentally miss out anything, then understand this can go wrong. Okay, so here we have done it perfectly so that there is no confusion. But make a note of this, and I request all of you to consider the way I have dealt with the numbers. Okay, so we can see for this question, 7 is to 4. That is our answer. Okay, let us go to the 10th question in this lot. Have a look at this question. We can see that here a cube has 4 of its faces blank. One face is marked 5 and the other it is marked 6. You can see that a cube, it has got 6 faces, out of which you can see that 4 it's blank, and the remaining 2 you can see that the numbers are there. Okay, 2 you can see that numbers are written. Okay, now 4 plus 2 it is equal to 6. Now look at this. In a game involving throwing this cube, rolling this cube, a person is said to have a success if he throws a numbered face. So just imagine I am rolling a dice and I am throwing it. If I see the number, then understand that it's a success. Okay, now 2 people, A and B, they are participating in this game. A throws the cube thrice, B throw it once. What is the ratio of A's chance of success to that of B's chance of success? Since B is throwing only once, let me say that probability that B wins, what it will be? Total number of outcome, it is 6. He may see any of those 6 faces. Total number of favorable outcome, if he sees the number 5 or if he sees the number 6, then you can see that he emerges as a winner. So probability that B wins, it is equal to 2 by 6. That is equal to 1 upon 3. Okay. Now, in the same way, let us consider the case, the probability of success associated with A. Okay, so A is making 3 trials, right? So let us consider that the probability that A fails in all the attempts. Okay, A fails in all the attempts. You know what it is? It is nothing but 4 upon 6 into 4 upon 6 into 4 upon 6. Listen carefully. A is rolling the dice thrice, right? So if A is seeing blank face, then A fails in the first attempt. What is that? 4 by 6. Second attempt also he fails. 4 by 6. Third attempt also he fails. 4 by 6. So probability that A confirmed failure in these 3 attempts, you know how much it is? 4 by 6 into 4 by 6 into 4 by 6, you know, that is equal to 4 into 4 into 4, which is equal to 64 out of 216. But this is the case where A fails. But we are not focusing on A's failure, right? We want to find out what is the chance that A succeeds. So, what is the probability that A wins when this guy is making 3 attempts? That is nothing but 1 minus 64 divided by 216. And on calculation, you can say this results in 19 upon 27. Okay, I have done the calculations for you already. 1 minus 64 by 216, when you do, it will be 152 divided by 216. Upon simplification, you can say this will come as 19 upon 27. Okay, so probability that B wins is 1 by 3. Probability that A wins, it is 19 upon 27. The question is, find the ratio of A's chance of success to that of B. So you are asked to find what is the probability that A is equal to win upon what is the probability that B is equal to win. You can see that is nothing but 19 by 27 divided by 1 by 3. Upon further simplification, I can say this results in 19 is 2. This is coming as 19 by 27 and 3 will get cancelled off. 9 times it will go. So 19 by 9 you will get. This is 19 is to 19. It is 19 is to 9 as you can see. Looking at the options, I can say option A reads 19 is to 9. That is my choice here. So, but before we say how this answer comes, you should have an idea how it actually works. Okay, so probability that B wins, it is simply 2 by 6 because B throws it only once. So for him to win, the chance is 2 out of 6, that is 1 by 3. As far as A is concerned, since you are rolling it thrice, I am considering the case where in all 3 he fails. That is 64 by 216. He fails. It is not that what we want. He wins. Okay, so we can see that there it will be like 19 by 27 it comes. 1 minus 64 by 216. You can say that comes as 19 by 27. Probably that A wins. Okay, now we can see that here the ratio P A win upon P B win, it is 19 by 27 by 1 by 3. 3 and 27 cancels off. It will come as 19 by 9, which is 19 is to 9, option A. Okay, so we have completed 10 questions now. Let us now go to the 11th one, question number 11. Okay, there are 4 parts here. Okay, 11, 12, 13, 14, like that we can consider. Look at this question. Kids and Toys Factory, it's the name of the factory. It is transporting balls of 5 different colors: yellow, blue, red, green, and white. Mr. Bolara, a worker in the factory, has to separate these balls as per the colors into different boxes and label them within the corresponding colored labels. And label them with the corresponding colored labels. Mr. Bolera after separating the balls, he sealed the boxes and then labeled the boxes at random. Okay, so it's that color of that ball right now, we may just ignore it. We can see that there is a box number 1, there is a box number 2, there is a box number 3, there is a box number 4, and there is a box number 5. Okay, so we can consider the question. See, these boxes are filled with the respective colors. All yellow balls, maybe. Okay, I'm just saying all yellow balls, all blue balls, all red balls, all green ones, and all white ones. Like this, it's filled. It's about labeling that we should be focusing on. Okay, now let us find out. There are 5 colors, So when you are going to stick the label, the color of that label, there are 5 ways you can take care of box number 1. 4 ways you can take care of box number 2. Okay, 3 ways for box number 3, 2 ways for this box here, and then finally the box that is remaining, 1 way. Whatever that is remaining, it comes over here. So the number of ways you can stick that label, that is 5 into 4 into 3 into 2 into 1. Just observe this only. The boxes are here. So when you're going to stick that color part, you can see that there are 5 labels here you can stuck, 4 labels remaining you can stuck, 3 labels remaining, which one you can stuck here, 2 remaining, 1 you can stuck here, whatever remaining, you stick it here. So there are a number of ways you can actually get this sticking the label in the boxes corresponding. You can say that is equal to 120. What is that 120? 120 is nothing but 5 into 4 into 3 into 2 into 1. This many number of ways, 120 ways you can stick that particular label onto these boxes. Now look at the question. All the boxes are labeled correctly. The question is, what is the probability for that? It's very easy, right? What is the probability that everybody is labeled correctly? I can see the answer. It will be 1 out of 120, right? It's something like, see, there are blue here, you are sticking blue. There are red here, you are sticking red. There are yellow here, you are sticking it that. There are white here, you are sticking it correctly. Okay, like that, when you are considering only one way, you can see that you can label all of them correctly out of 120 different options you had in front of you. So the probability that all the boxes are labeled correctly, it is 1 by 120. That is for the first question in this lot. Okay, in the same way, at least one box is labeled incorrectly. So this is all like playing with words. Probability that at least one box is labeled incorrectly. So what I am going to do here is, first I will find out what is the probability that none of the box is labeled incorrectly. Okay, what is that? We will just see none of the boxes is labeled incorrectly. What does that mean? Double negation. Probability that all boxes are labeled. What does it come? All boxes are labeled correctly. Okay. I will put it in this way. Listen. They are asking you to find what is the probability that at least one box is labeled incorrectly. Okay, because be careful here. Incorrect, no, not, never. They are all coming multiple times. Okay, so there should not be an error. The question is, what is the probability that at least one it is labeled incorrectly? So first I will try to define what is the probability that no box is labeled incorrectly. What does that mean? It means that probability that none of the box labeled incorrectly means what? What is the probability that all are labeled correctly? All are labeled correctly. Okay. What is that? That value we already calculated. It is 1 by 120. Now, in our question, it is not what they are telling you. It says that at least one box is labeled incorrectly. What is that? That is nothing but the negation of this situation. So my answer will be 1 by 1 by this 1 minus 1 by 120. You can see that results in 119 divided by 120. Be careful with this, okay? So option D, it reads that way, 119 by 120. That is going to be our answer. So this question, sometimes, you may get confused slightly, but it's actually easy one. The question is, what is the probability that at least one box is labeled incorrectly? It is nothing but 1 minus what is the probability that no box is labeled, no box is labeled incorrectly. If you are analyzing it, this is as good as 1 minus probability that all are correct, all are labeled correctly. And that is as good as 1 minus 1 by 120. And that results in our answer 119 divided by 120. Option D, it reads this, and that is going to be my answer. Okay. Now let's go ahead with the next question. Exactly one box is labeled incorrectly. The answer is, using common sense, you can say the answer is 0. It is never going to happen. Why, I will tell you. Just imagine 1, 2, 3, 4, 5. Okay, 5 are there. Okay, let me say that this has got yellow balls. This has got blue ball. This has got red ball. It has got green. And this has got white. Just imagine I made an error here. Yellow ball, here I stuck the label as red. Okay, I stuck the label here as red. See this, for the yellow ball, this box I stuck the label as red. I made an error here. Automatically I can say, even if I am doing this blue labeling correctly, green labeling correctly, the white labeling correctly, even if I am going to do it, I can see the box that contains red colored ball, I cannot label it correctly. This will also go wrong. Okay, so the question is, exactly one box is labeled incorrectly. When the question comes, I can see that is actually not possible, because when one goes wrong, on the other side, another one will also be going wrong. So this answer, it is equal to 0. Okay. And the last question in this lecture, all the boxes are incorrectly labeled. That is the question. Yesterday, we discussed about the concept of derangements. There are 5, right? So all 5 are labeled incorrectly means you are asked to find this case where derangement of 5 it happens, that is equal to 44. So there are 44 ways in which D5, derangement 5, D5 is nothing but 44. So there are 44 ways in which you can consider that all the labels are incorrect. Now the question is, what is the probability that all are labeled incorrectly? It's not about the number of ways in which you are labeling them incorrectly. It's about the probability. Okay. So what is the probability? Probability will be total number of favorable outcome divided by total number of outcome. It is 44 upon 120. Cancelling it with 4, you have 11 upon 30 that actually comes here. Okay. So as far as question D it is concerned, my answer will be 11 upon 30. And with this, we have completed altogether close to 15 questions in this lecture. So there are a few more questions based on probability, which we will be discussing in our subsequent lecture. So with this question, I am concluding this video session. All right.